In this presentation, we are going to talk a little bit about serverless approach of ingesting data into your data warehouse, and then we're going to showcase an example of how we can use different AWS services in order to achieve that. We are going to deep dive into each separate service so that we can see how they work. First, a little bit of introduction. So why serverless? So there are multiple reasons why companies migrate from the traditional, let's say, the on-premise architecture and solutions to the cloud. Whether they want to reduce costs, they want to reduce complexity, or maybe they want to improve their quality of their product or the service that they're offering. Another reason is maybe the company is growing and the hardware that they have doesn't scale anymore, so it won't be able to do its job. Also, over time, the same company can change their reasons. For example, if they achieve the cost reduction, now they have more room to be more innovative, and then by being more innovating, they can get recognized on the market, and they automatically grow, so they still have the same issues like other companies had. On the leading part of the graph, we can imagine companies that want to be completely different from everybody else from the market. So they will most probably use some experimental technologies or techniques in order to achieve the serverless architecture. And they can be called, let's say, trend-setting companies. We don't have to migrate from the on-premise to the cloud immediately or in one jump. The typical customer's migration path includes multiple iterations. So we start with some experimentations of only one feature, and then we learn a lot from it. So we step into some limits, some challenges, and then based on those, we adapt and we create a production-ready version. After, when we notice that there is actually a good value from going to the cloud, then we keep expanding our features with more features until basically we end up going all in, and at that in that point of time, we can say that those cloud solutions are actually part of our corporate standard. Okay, so Amazon offers a lot of different web services that can help us build our own serverless architecture or solution. So we will not have to provision anymore about the hardware, the scaling. We don't have to buy a completely new rack in case the older one is outdated, and we don't have to manage low-level configurations that has nothing to do with our business, but we can now focus on doing what we want to do, which is focus on our core product or solution. We will start with the example, with the use case, where we have actually two different processes. They work in parallel, and one is event-driven and one is about streaming data. So the first one is regarding a weather forecast company that creates weather reports on daily basis and actually multiple times in one day. Our goal here is to collect the latest report. So whenever there is a change, we want that change in our solution as soon as possible, and we want to immediately process those files and integrate it into our Amazon Redshift data warehouse. Then on the other side, so for the streaming process, we have the source is a data stream. So basically we have a live feed that is constantly producing data about aviation, so aviation flights. We are getting information about flights and their relative positions. So basically, we are getting the coordinates on the map. The reason why we are interested in these two subject areas is our final goal is for the reporting team to get their data clean and prepared so that they could compare the data and see if there is any correlation whether the weather conditions are affecting how the flights are being, let's say, delayed or being redirected to some other airports that were not initially in the plan. So in the second part, so in the streaming, we're going to use EC2 instance because we had to create a publisher that will actually listen to the live broadcast and, let's say, redirect the data to our solution. So we will push the messages to the Kinesis data firehose. And then firehose is going to leverage the rest of the process where it will initially land the data in S3 and then efficiently use the copy command to load the data into Redshift. The last part of the process is going to be a custom-made ETL framework that will help to process and clean the data in order for the reporting team to have their data ready. Okay, so let's start deep diving in each component. So the S3 is the object storage. We will use it to store any kind of data. Here, mostly the landing files that we are getting from the outside world. So for the event-driven process, we are using it as a file drop for the incoming data, and immediately as the file drops, it triggers a Lambda execution. So immediately the data is going to be cleaned up and stored into Redshift. The second part is going to be used as an intermediate S3 bucket, where we're also going to keep those files there and make it as a backup. So in case later on some data gets deleted in accident on the Redshift, we're still going to have the backup in our S3. This is one example. So basically the S3 looks like a simple folder structure, a file system, but there are additional customizations upon it, on the buckets. So we enabled the object level logging, which is given thanks to the CloudTrail service. We can check in detail all the changes that are happening to our files. It's more a security precaution. And even though we didn't enable the KMS, the encrypting of the objects, which would be another step of security. If you have sensitive data, it would be a smart idea to have it. Now, regarding the events are the ones that are going to trigger the lambdas so that we can process the data. We can choose on which folder do we want to follow changes, and whenever a new file is created, we're gonna say create an event, run that specific lambda that is designed to specifically handle that type of file. Okay, so Kinesis data firehose is the second one, and it's used to process and distribute data streams. So in our case, we are not going to have a custom transformation inside it, even though it is a possibility. The reason why we just want to land our data into Redshift is because the ETL framework later on is going to take care of cleaning up the data how we want. So why do we need it then? We need it for multiple purposes. Kinesis Firehose offers the buffering of data streams. So when our data producer is sending messages, sometimes in our system there can be some bottleneck or some downtime, so we don't want to lose any message. So Firehose is storing the messages in the buffer, and there is also a fault-tolerant option to make sure that if some message fails, it will retry until it's successful. So we're going to buffer the data streams. We're going to back up messages in S3, as said before. And we're going to, of course, land data into Redshift. That's our final goal. As you can see here, the transformation is disabled, and there's also an additional option of making a backup. However, in the intermediate S3 destination configuration, we have an option to choose when the file is being processed. Do we want to keep it, or do we want to delete it? So if the file is processed, delete it. In this case, we decided to keep it, so that intermediate S3 bucket is actually serving as a backup. Other than that, so Firehose is also dealing with incremental loads, as we can see here. And the only limitation here is the 60 seconds time frame where Kinesis is collecting messages and forwarding messages to Redshift and processing. So the issue here is that if your flow doesn't send so many messages, is 6 seconds enough for you? So basically, if you're trying to do a real-time solution, maybe 6 seconds is a long time to wait. So that's why Firehose is more understood as a near real-time solution than the actual real-time. One more thing, the CloudWatch service is also implemented into the data Firehose, where we can see through the metrics how the data flows. Here we can see, so the data didn't even come into Redshift, and we didn't do any report, but we can already see that depending on the data of the flights, that we have rush hour usually around 4 o'clock p.m. So it's really handy even for troubleshooting to see what's going on with our data and if the stream stops streaming and similar. Okay, so Lambda. Lambda is serves to run code without provisioning or managing service, so basically the pure serverless service. We can write the code in one of these languages as you prefer. And in our case, we use it for the MN-driven process to fetch and to prepare the data and to insert it into Redshift. The second part is part of the ETL framework that I will talk a little bit later, is it will execute the SQL for each step that we want, for each ETL job that we want to clean up the data. And the third one that is also on the list is to run a database maintenance tasks. So we want to trigger the vacuuming of the warehouse and the analyze command here and there, so that we optimize our database and we make sure that the data stored is partitioned well. Okay, so we can see here an example, and thanks to the Cloud9 service that was implemented on later occasion, we can edit the code directly from the browser. So we don't have to do it locally and then upload it. We can open the Lambda within the browser and we can edit the code straight away. We can see here an example where we have one business step that is actually running the SQLs that we want, and around that we have some ETL control table scripts that we also log so that we know if something went wrong with the job or not. Even though Lambda also can give you an error message, so you would also be able to see if something went wrong. Okay. Here the biggest limitation is actually the timeout. So the timeout settings. The timeout was, the maximum limit was 5 minutes, which is concerning a little bit, because what if your ETL runs more than 5 minutes? So there are multiple solutions for that, whether to create an async solution, so giving the command to Redshift and then the Lambda is done and the Redshift is doing the rest of the job, and then we need to go back and check what's the status of that query. Or the second one is to break down the query so that we have many less jobs, smaller jobs distributed. Luckily, they decided to make the limit higher, so now it's 15 minutes, and 15 minutes is quite all right. This is a latest change. Okay, now to connect these lambdas, we have the AWS step functions. So here now we are making a workflow. So we want to orchestrate all those lambdas. So in order to coordinate lambdas, we connect them together with step functions. Okay, so the goal here is to create a ETL framework that will work effectively no matter what the scale is. So another thing here that we mentioned is we also use, through the step function, we also run some extra queries that we want, for example, caching the results for our other team, the enterprise voice, where since we're already dealing with that data, we can help them out and cache some data to make Alexa a little bit faster. Okay, so how does it look like? On the left side is where we write the instructions, and basically, as soon as we make a change, it shows in the visual workflow. So it's maybe easier for me to explain from the workflow. The point of framework is no matter how many jobs we have, it's going to be the same step function. We don't need to change it, and it will work even if we have one job to run or if we have 200 jobs to run. Okay, so the point here is to read some ETL steps that are stored somewhere else. So it's either stored in some configuration file, or it's stored in some database, or it can be in DynamoDB, it can be wherever we want. In this case, it's stored in a JSON array, so each element in the array is going to be one job. The reasons why we have some information storing in the array is because for the execute ETL step lambda, we're going to need some parameters so that we know what are we trying to load and where we can find the definition of the SQL and similar. So we can see, for example, that the SQL for loading the table, the invoice type, is located in S3 folder, and the table is going to be between the EDW schema, and there is a specific also control table. So how the flow goes. So read ETL steps, now execute steps one by one, and after one is done, check the result. If there are more steps to go, then go back and keep iterating until all the jobs are done. The only limitation here is that the inputs are limited to 32,000 characters. So if you have let's say, 500 jobs, you might end up with exceeding that limit, and that's why there's also another option of limiting the steps that has to be run. So we can call the step function first time and then set step 1 to 100, and then call it the second time 101 to 200, and similar. That's why we won't break the limit. Okay, and the last service used is the CloudWatch. CloudWatch is a multifunctional service because it serves as for monitoring, so we can see the KPIs as we saw in the Firehose and the Lambda. We can also schedule stuff, so we can schedule this step function with the CloudWatch event, or we can have time-driven events also. So we use it to schedule step functions, to monitor operational KPIs, and publish alerts to notification topics. So we will see here in the next slide that the example of the step function running every 5 minutes, and if the previous step function is running, it's not going to run again. Also here in the alarm, we can see that based on the KPIs that CloudWatch offers, we can also trigger some notifications. And in this case, if the error threshold passes 0.5, so if it's bigger than 0, it can only be 1 or 0. So in that case, it will trigger a notification, and the notification will be sent to a specific email list, whoever is actually subscribed to that specific topic. And we're back to the overview. So basically, with all these services, we managed to make a scalable solution that works for any size. From ingestion, the same warehouse, and the ETL framework. As we can see, there are not so many services. So thank you very much. Do you have any questions?
Just one, if I remember correctly. Hey, Filip.
Hey.
Wasn't there some option about lambdas being synchronous and asynchronous lambdas?
Well, you can write your code asynchronous if you want. So you can make. It's okay if your Lambda timeouts because he already sent the command to Redshift, so Redshift took and already started doing the work. So now, once your Lambda gets terminated, there is no way of checking that, but you can use your next Lambda to go to the database and then check the logs, check the activities to see what's going on with that specific query. So there is the query log.
That's how we can escape those previously 5 minutes and now 15 minutes, right?
Yeah, now it's 15 minutes, and 15 minutes is quite all right because, I don't know, when you design the ETL jobs, it depends on the ETL job, of course, but you want to be inside some frames.
Thank you.
Want to optimize. You can always split the ETL jobs into multiple parts. Thank you very much. More questions?
Well, thank you. Thank you
Thank
very
you.
much.